Welcome to you all. Today we're going to learn measures of dispersion. There may be a question. We already have the averages. Then why we need the measures of dispersion? The question quite arises naturally. Now to answer that question, we're going to learn what is the averages explains about. Now here the averages which we learned is not enough to describe given data because there exist a number of distributions whose averages are same but differ widely in structure from each other. Example here we're going to learn, that is in a series X, Y, Z, three different series here we given. In a series X, here is a 10, 10, 10, like 9 numbers. Number of tens is 9. Adding all the numbers, we're going to get the 90. So that is the mean of the X mean equals 10. In this particular series, the number is 9. Okay, 9 numbers and the total of all the observation is 90. Now, mean equals 10. And the second series, here we can see that the data is moderately distributed. 6, 7, 8, 9, 10, 11, 12, 30 and 14. Now here sum of all the observations of Y divided by its number, once again 9, equals 10, the mean which we get. And here in the series Z, that is 2, 3, 5, 7, 10, 13, 15, 16 and 19. Of all these observations adding together, we're going to get 90 and divide by its numbers, that is the 9 numbers equals 10, we're going to get 4, 5 for 9 numbers. That is, in all this observation, what we understand here, all the examples what we learn, all the three threes have the same size and the mean. The size is 9, number of observation, and also mean also be same 10, 10, 10. But the nature of the distribution of the values is different. From one series to other, the value of distribution may be different. So here, what do we understand? In that study, in that above, what we learned here, the variation of values from an average. The average is here 10. The variation of these values from the mean values is known as the measures of dispersion. So let us learn the definition of the measures of dispersion. Here, the measures of dispersion says the study of scatter or variation of values in a data. Here, scatter or the variation of different values in a data from any measures of central tendency is called as a dispersion. Here, any measures. Here in this case, we're going to have the mean, or it may be a median, or it may be a mode. So any measure of central tendency is called as a dispersion. In simple, we understand that the measures which measure a lack of uniformity is called as a measures of dispersion. Now all the data, so here the size is the same 9 and the mean also same, but what happened, the data is lacking the uniformity in the observation of three series. In the very first one, they uniformly distributed the values, and the second, it is a moderately distributed, and the third, there is a more variation. That is why the data is lacking uniformity in the second and third observations. So, and that's why we need to learn the measures of dispersion. So what is the objectives of learning the measures of dispersion? Here, to judge the reliability of an average, there's a one important aspect. To compare two or more series with respect to its variability and to serve as a basis for the control of the variability and to enable the use of other statistical measures, other statistical tools. And this is the main objective of measuring the variation. Now, in the what is that measures of dispersion, we have two different types, that is absolute and relative measure of dispersion. So what is the absolute measures are there? Here it is an expression. The variation are expressed in the same statistical units. So same, if the same units we are expressing, then such kind of data, such kind of same units like rupees and kgs, okay, if you measure it, then that is called as a absolute variation. So these measures are used to compare or two or more distributions, provided the data express the same units, not different units. So if the data are expressed in different units, a comparison of variation is required because different units a given data we are expressing, and then such kind of cases we call as we use the relative measures of dispersion we are used. In simple, we can say that relative measure of variation is one in which independent, okay, is one which is independent of units of measures of variable. So relative measure is independent units of measure of variable, and it is very suitable for comparative study of variation. Now here there are types of measures of absolute measures and relative measures of dispersion we are going to learn. Now in this case there are types of absolute measures of variation, in that range, the first one, and second quartile deviation and mean deviation and standard deviation. These are the four absolute measures of variation we can find it. Then apart of that, there is also have the relative measures of variation if you are comparing different units of measurement, and that time we have already absolute range. Here is a coefficient of range. The quartile deviation, we have a coefficient of quartile deviation. Here mean deviation, here coefficient of mean deviation. When standard deviation in absolute, in a relative measure we are going to have the coefficient of standard deviation or covariation. Let's learn the range in clear. Now here range in simple, we know that it is the difference between the highest value and the least value. So here in our observed values, as we know that here we given that three series, here highest value and the lowest value or least value. So what is the difference between the highest value and the lowest value, and how the data is measured or variation, and that can we understand. So it is the difference between the highest value and the least value in a given observation, in a given data, and it is denoted by R. So the formula for finding the range is equals R equals highest value and the least value minus of least value. Now what about the relative measure of that is a coefficient of range? It's very simple. Highest value minus least value divided by highest plus least value. So this is all for the day. Thank you for watching.